In this section, we're going to talk about absolute value equations. So objectives, we're going to evaluate and graph the absolute value function. We're going to solve absolute value equations. So the absolute value function, f of x, is equal to the absolute value of x. And that is technically asking you how far away is x from 0, regardless of in what direction. So I'm going to make a table. So I'm going to pick 0, 1, -1, and 2. So the absolute value of 0 is how far away is 0 from 0? It is 0. For x equal to 1, how far away is 1 from 0? So the absolute value of 1, it's 1 space away from 0. For the next one, the absolute value of -1 is how far is -1 away from 0? It's 1 space away, again, regardless of left or right. And the absolute value of -2 is asking you how far away is -2 from 0? It is 2 spaces away. So if I want to graph this, this is going to be 0, 0 for the first point. I'll zoom in here. 1, 1, -1, 1, 2, 2. Excuse me, this is -2, so that's the reason why this negative and that negative. So -2, 2. And if I continue the pattern, on the left-hand side, it's 1 up, 1 to the left. So here I go. Sorry for the background noise. And for the right part of the graph, 1 up, 1 to the right. And we can continue this pattern forever to the right, and the 1 up, 1 to the left, forever to the left. Okay, so our domain, again, is our x's. And it's going to be lowest x, comma, highest x. And so our lowest x, this part of the graph is going forever left. So it's going to be -infinity, always with a parentheses. And this part of the graph is going forever right. Shucks. It's too dark. Forever right, so that's going to be +infinity with a parentheses. Our range are our y's. So it's going to be the lowest y, comma, the highest y. So our lowest y is going to be the y value at this point. So the y value, so this point is 0, 0. So technically I should say that the y value is that number right there. So that's our lowest y value. And it is a point on the graph, so it's going to be bracket 0. And our highest y value technically is a combination of these two arrows here going forever up. So forever up is going to be infinity with the parentheses. Now, increasing and decreasing, you need to remember, is in terms of your x's, which is your domain. So the function is increasing from this point here. So for increasing, it's going to be lowest x, comma, highest x. And so the lowest x is going to be 0. And the 0 that I'm referencing is this one right here. That's the same darn color. This 0 right here is this 0 right there, with a parentheses always. And the highest x is technically this blue arrow, the same blue arrow here, because we're going forever to the right. it's going to be infinity with the parentheses. Now, decreasing. So for decreasing, it's going to be from this point here, this way. That's decreasing. Again, because it has this downward trend, like a negative slope. And so it's still going to be lowest x, comma, highest x. And because of the green arrow that I'm probably not going to be able to reproduce anymore. Hope it's this one. Yeah, it is. This green arrow right here, my lowest x is technically going forever left. So that's going to be negative infinity. And my highest x is at the same red right here. And so it's going to be comma 0. And it's going to be a parentheses. Always. So for increasing and decreasing, when you have numbers, you're going to put parentheses around them all the time. And for infinities, you're going to put parentheses around them as well. All right, example. So let me come over here. Oh, so on this over here, right here, these are different representations of the formula for the absolute value of x. So this is a piecewise function right here. And it says the absolute value of x is equal to negative x if x is less than 0. That is technically the blue part of the line again right here. That's this one. And then it's going to be x if x is greater than or equal to 0 is the gray line. And then the second representation, this absolute value of x is equal to the square root of x squared. This you need to remember that technically when you take the square root of a number, it's positive. It's both a positive and a negative number. So for example here, if I have the absolute value of 25, it's the same thing as the square root of 25, which technically gives you two answers, positive 5 and negative 5. Okay, so example. F of x is equal to negative 3x minus 3. And so part A says graph f of x. Okay, so f of x is going to be negative 3x minus 3. And technically I only need 2 points, again, because it's a line. But I'm going to do a little extra here. So this is going to be negative 3 times a negative 2, which is positive 6, minus 3 is going to give me 3. So negative 2, 3. Can zoom in here. So this is going to be negative 3 times a negative 1 is 3 minus 3 is equal to 0. So negative 1, 0. Negative 3 times 0 is 0 minus 3 is negative 3. So 0, negative 3. Negative 3 times 1 is negative 3 minus 3 is negative 6. Negative 3 times 2 is negative 6 minus 3 is negative 9. And so this is technically what, and if I continue the pattern, it goes 3 up, 1 to the left, 3 up, 1 to the left. If I were to connect those dots, I would have the line negative 3x minus 3. So that's part A. Part B says use part A to sketch the graph of y equal to absolute value of f of x. So this is actually going to be the absolute value of negative 3x minus 3. So all I'm going to do is I'm going to get the y values and I'm going to take the absolute value of them. So this is going to be 3. So my x value is still negative 2, but now my y value is 3. So I'm going to graph those. So negative 2, 3 is still this point. And then for the next one, it's going to be the absolute value of 0, which is 0. So negative 1, 0 is right there. And then the absolute value of -3 is 3. So this is going to be, instead of 0, -3, it's not going to be 0, +3. And then instead of the absolute value, excuse me, instead of -6, it's going to be the absolute value of -6, which is +6. So this is 1, 6. And then instead of -9, excuse me, it's the absolute value of -9, which is 9. So our graph, technically for the absolute value of -3x minus 3, is this graph right here. So if you notice, how can I highlight? These points that have negative y values turn into positive ones. So this negative y value turns into a positive one. And this negative y value turns into a positive one. So the graph in gray is your answer. All right, let's continue answering these questions. So we did part A, we did part B. Part C says determine the x-intercept. So for part C, the x-intercept, as a reminder, is the point on the graph that is on the x-axis. So the point that is on the x-axis is this point right here. And so that's going to be -1, 0. And so if it asks you on the homework for the point, you're going to put this in green. If it asks you just for the x value, which is technically the zeros, you just put -1. All right, so for part, what else does it say? Okay, that's C. Then for D, it asks, determine where the graph is increasing and where is it decreasing. Okay, so it is increasing. I'm going to highlight it in yellow. It's increasing from this point and then continuing in that direction forever. So that's increasing. And again, it's always going to be lowest x, comma, highest x. And so my lowest x value is -1, always with a parentheses. And my highest x is going forever to the right, which is going to be infinity. And the forever to the right is this arrow right here. That's forever to the right. Okay, it's also asking us when it's decreasing. So when is it decreasing? Decreasing is going to be this part of the graph starting from this point and going this way. That's when it's decreasing because it has a downward slope. So it's going to be decreasing, still again, lowest comma highest x. So this is going to be lowest x comma highest x. So my lowest x goes forever to the left, so it's going to be -infinity, and it is because of this arrow right here going forever to the left. And then my highest x is going to be -1, always with a parentheses. So for -1, the reason why it's -1 is because of that point right there. And then part E asks us for the domain and the range. Okay, so for part E, I'm going to put it here. So the domain are my x's, and it's going to be the lowest x, comma, the highest x. So my lowest x, because of this green arrow, is going forever to the left. So that's going to be -infinity, always with the parentheses. And then my highest x, because of this green arrow, it's going forever to the right. So it's going to be positive infinity, always with a parentheses. And my range are my y's. So this is going to be my lowest y, comma, my highest y. So my lowest y is going to be, what color can I use? My lowest y is the y value at this point right here. So my y value, the point is -1, 0. So my lowest y value is that right there. So my lowest y is 0. And this one is going to be with a bracket because it's an actual point on the line. So remember, the only time you use parentheses is when you're doing increasing and decreasing. For domains and ranges, if the point is an actual point on the graph, you're going to put brackets. And for infinities, positive or negative, you always use parentheses. All right, so lowest y is 0. And my highest y, because of these two arrows, they're going forever up, is going to be infinity. So you can pause the video and try the next one on your own. And if you notice, I didn't use a graphing utility. You can graph it using your graphing utility. It's all up to you. So here on this one, so we have f of x is equal to the absolute value of a half x plus 1. And so for part A, we're going to graph it. So I have x and I have f of x equal to absolute value of a half x plus 1. And I pick some points here. So this will -10. And so I'm going to do a half of -10 is -5 plus 1 is -4. And the absolute value of -4 is 4. So -10, 4. For -6, so I'm going to take half of -6, which is -3, plus 1 is -2, and the absolute value of that is +2. And so for -2, it's going to be half of -2, which is -1, plus 1 is 0, and the absolute value of 0 is 0. For 4, I'm going to take half of 4, which is 2, add 1, which is 3, and the absolute value of 3 is 3. Oh, hang tight. Right here. And then for 10, half of 10 is 5 plus 1 is 6. Absolute value of 6 is 6. So for 10, I get 6. One, two, three, 4, 5, 6. Okay. It'd be nice for us to make the connection that this 1/2 is technically our slope. So I can go from this point, 1 up, 2 to the right, 1 up, 2 to the right, and I end up with the points that I had already done. Now, for the other side, it would be 1 up, 2 to the left. So 1 up, 2 to the left, 1 up, 2 to the left, 1 up to the left, 1 up to the left, and I end up with the same points that I had already previously plotted. So if you notice, we've done an absolute value graph 3 times. And so an absolute value graph technically always looks like a V. So graphically, always, and I stress the always, looks like a V. Oops, getting lazy there. Looks like a V. All right. So those of you that are wanting to make tables and not use a graphing utility, just make sure that you get enough X values so that you're able to see the actual V. If you just continue going on one side and you just end up with a line, that is not an absolute value graph. So just heads up. All right, part B, find the x-intercept. So again, the x-intercept is the point on the line that crosses the x-axis. So the x-intercept is this point right there. So it's going to be -2, 0. That's my x value, the -2, and the 0 is my y value. Then part C, determine whether the graph is increasing and decreasing. Okay, so increasing is going to be from this point. That's not what I want. From this point this way is increasing. And again, increasing is always lowest comma highest x. So my lowest x is at this point right here, and this is going to be -2, 0. So my lowest x is -2, always with a parentheses. And my highest x, because of this arrow right here, it's going forever to the right, is going to be positive infinity. As for decreasing, which is going to be the green highlighted part right here, it is going to be still lowest x, comma highest x. So the lowest x is going to be negative infinity, again because this arrow goes forever to the left, always with a parentheses. And my highest x is going to be still this -2, because that's the furthest right part of the green shaded part of the graph. So this is going to be -2, always with the parentheses. Now, for part D, it says determine the domain and the range. So the domain are my x's, and I'm going to write it as lowest x, comma, highest x. Okay, so my lowest x for the entire graph. This arrow is going forever to the left. So forever to the left is going to be negative infinity. And my highest x is the rightmost part of the graph. So this arrow right here is going forever to the right. So it's going to be positive infinity, and both with parentheses. Now the range is the only time that we're dealing with the y's. So this is going to be the lowest y, comma, the highest y. So my lowest y is the lowest point on the graph, and I'm going to pick something that I haven't used. So the lowest point is this point right here, and the lowest y value is 0, and it's an actual point, so it's going to be bracket 0. And my highest y value, because of these two arrows going forever to the right, forever up, is going to be infinity with parentheses as usual. So now we're going to solve absolute value equations. So absolute value equations, number one, if k, so what is k? So this k is whatever your absolute value equation is equal to. So if k is greater than 0, which is technically another name for a positive number. So if this greater than 0 means that if k is a positive number, then you have two solutions. If k is equal to 0, then you have exactly one solution. And if k is less than 0, then you don't have a solution because absolute values are always 0 or positive. There's no negative answers here. All right, so example, solve the absolute value equation. So I have the absolute value of negative 3x minus 3 is equal to 6. So I'm going to solve it algebraically first, and then I'll show you graphically what is going on. So I have the absolute value of negative 3x minus 3 is equal to 6. So since 6, so we have two solutions. Since 6, which is our k, is greater than 0. So the two solutions are going to be, one of them is going to be just take the absolute value, whatever's inside the absolute value, which is negative 3x minus 3, set it equal to 0. And the other one is going to be get whatever's inside the absolute value, which is negative 3x minus 3, and set it to the opposite of 6, which is going to be negative 6. And then we have two equations that we have to algebraically solve. So the first one here on the left-hand side, to get rid of this minus 3, we're going to add 3 to both sides. I wish, hang tight. I'm going to change that to black permanently. Okay, so negative 3x, the minus 3 plus 3 simplify to 0. 6 plus 3 is 9. Then we're going to divide both sides by negative 3. And these simplify to 1 times x is equal to x. And 9 divided by negative 3 is negative 3. The next equation, I'm going to still add 3 to both sides. On the left-hand side, I'm left with negative 3x. On the right-hand side, I'm left with negative 6 plus 3, which is negative 3. And then I'm going to divide both sides by negative 3. Again, these simplify to 1 times x is just x is equal to negative 1. So I have two answers. Now, if I don't want to check it graphically, I can check it algebraically just by substituting. So let's check. So for this answer right here, it would be, excuse me, absolute value of negative 3 times negative 3. So negative 3 times negative 3 is positive 9. 9 minus 3 is 6. And then the absolute value of 6 is in fact 6. So that's true. And then for the next one, I think I'm going to do it a little bit more clear here. So it's going to be negative 3 times negative 1, which is 3. And then I do, hang tight, hang tight. So my answer should be positive 1. Sorry, because a negative divided by a negative is a positive. So negative 3 times a positive 1 is negative 3. And negative 3 minus 3 is negative 6. And when I take the absolute value of negative 6, I get positive 6. So yes, that works. Now, graphically. So let me get here Desmos. Let me put my notes here to the left. They're upside down. Okay, here they go. Okay. I was about to have a heart attack. Okay, so absolute value. So on Desmos, it's this key right here. So it's the absolute value of negative 3x minus 3. And I close the absolute value symbol. So there is that v. It better look like a v because it's absolute value. And I want to, so y equal to 6. So if I don't want to think too much, so the right hand side, which that's 6, I'm going to enter it as y equal to 6. And if you, the nice thing of entering that equation is that the x value is negative 3, which is this x value right here. And then this other point is 1 comma 6. And so that positive 1 is that answer right there. So we want to know when the absolute value of negative 3x minus 3, which is that v, crosses or intersects with the line y equal to 6. And Desmos confirmed our answer. All right, so the rest of these, you can check them with your graphing calculator. I'm going to do them algebraically. So I have the absolute value of 1/2 x plus 1 is equal to 0. So on this one here, we have one solution, since 0, which is our k, maybe I should put a k here. This is our k. Our k is equal to 0. So we just take whatever's inside the absolute value symbol and set it equal to the right-hand side of the equation. And then just algebraically solve. So to get rid of 1, we're going to subtract 1. And we're going to be left with 1/2 x is equal to 0 minus 1 is negative 1. And the 1/2 is multiplying. So to get rid of a multiplication, we're going to divide both sides by 1/2. And hopefully we can, so 1/2 divided by 1/2 simplifies to 1. Times x is equal to x. And negative 1/2 divided by, negative 1 divided by 1/2. So first of all, a negative divided by a positive is going to be a negative. And then 1 divided by 1/2, if you use your calculator right, is 2. So if you do negative 1 divided by 1/2 correctly on your calculator, you should get negative 2. Now let's check our answer. So it's going to be 1/2 of negative 2, which is negative 1. Negative 1 plus 1 is 0. And the absolute value of 0 is in fact 0. So it does work. Let's do some other examples. Again, you're more than welcome to pause at any time and try to do these on your own and then play the video to check your answers. So the next one is negative 8x minus 11, absolute value of that, is equal to negative 7. So here on this one, it'd be nice for us to say, oh, so we have an absolute value on the left-hand side. And on the other side, we have a negative answer. And we can't, the absolute value of anything is always going to be a positive number or 0. So this one is no solution. And we could stop right there. If you could remember that. I'm going to go ahead and go through the motions. And you're going to see that we're going to get some answers. But when we check them, they're not going to work. So if you forget, then you're going to say, oh, it has 2 solutions. So I'm just going to put here, this is unnecessary work. Just an FYI. So negative 8x minus 11 is equal to negative 7. And then the other one would be negative 8x minus 11 is equal to positive 7. And so I'm going to add 11 to both sides. And I get negative 8x is equal to negative 7 plus 11 is going to be 4. And then I'm going to divide both sides by negative 8 to get rid of that negative 8. So negative 8 divided by negative 8 is an understood 1 times x is going to give me x. And this is going to be negative 1/2. So if I check my answer, I'm going to do negative 8 times negative 1/2. So negative times a negative is a positive. And half of 8 is 4. So it's going to be 4. Minus 11 is negative 7. And when I take the absolute value, I'm going to get 7. And 7 does not equal to the negative 7 that we want as our answer. So therefore, x equal to negative 1/2 is not a solution. Let's do the next one. What if we have, so for this one, we would do the same process except that we're starting off with positive 7, not negative 7. So we're going to add 11 to both sides. And I should technically say these simplify to 0. And I'm left with negative 8x is equal to 11 plus 7 is 18. I'm going to divide both sides by negative 8 to get rid of the negative 8. Negative 8 divided by negative 8 is 1 times x is equal to 18 over negative 8 are two even numbers. So they're both divisible by 2. And technically it's negative 9/4. And so I'm going to check my work. And this one's going to be a little bit more interesting. So negative 8 times negative 9/4. Well, a negative times a negative is a positive. Okay. And so 8 divided by 4 is 2. 2 times 9 is 18. So I have 18 so far. And then I'm going to subtract 11. So 18 minus 11 is 7. And the absolute value of 7 is 7. And again, it's not equal to the negative 7 that we want. So therefore, so my three little dots are therefore. X equal to negative 9/4 is not a solution. So even though you don't, if you don't want to remember the steps and you just say, oh, I'm just going to set it equal to the whatever's on one side, the number that's by itself, positive and negative, and you do all the work, then make sure you check it because you might end up with them being no solution. Okay, so the last one is this absolute value of negative 3 minus 3x, and then minus 2 is equal to 2. So the only difference between this last equation and the other ones is that the absolute value on the left-hand side was already isolated. So you need to isolate the absolute value first. So I'm going to put this very important up here. You need to isolate the x value first. The absolute value. Jeez Louise. And I'm going to draw a line going down to this one down here. I'm going to go ahead and change to this one. I'm going to change this to a negative 1. And I'm going to change this to a minus 4. And here's the reason being. Some of you might think, oh, well, based on the problem we just finished, it's going to be no solution because this one right here is negative, and so it's no solution. Not quite. And the reason being is because this absolute value right here is not by itself. So I'm going to have to isolate it first. So I'm going to add 4 to both sides. And so now I'm going to be left with absolute value of 3 minus 3x, absolute value, is equal to 3. And so now we know that there's two solutions. In fact, let's show you first on the graphing utility. So here, okay, be nice to me, technology. I have absolute value of 3 minus 3x, close it, and so there it is. Oh, and I'm going to do minus 4, because that's the entire left side of this equation right here. All of this. Well, hang tight. It's all of this equation. And then in the other line in decimals, I'm going to put y equal to negative 1, which is what's highlighted in yellow. So if you notice, they do intersect. And so our answers should be 0 and 2, because we're looking for the x values. So they should be 0 and 2. So let's see. Here we go. Sorry for the background. So here on this one, we have two answers. We have two solutions. So we're gonna do 3 minus 3x is equal to 3. I'm sorry, 3 minus 3x is equal to negative 3. and we're going to solve for x. So we're going to subtract 3 from both sides. And we're going to get here, this simplifies to 0. Minus 3x is going to give us negative 3x is equal to 0. Divide both sides by negative 3. So negative 3 divided by negative 3 simplifies to 1. Times x is equal to 0 divided by negative 3 is just 0. So that's one of the answers that we got. And the other one, we're going to do the same process, but we're going to start off with negative 3 on the right-hand side. So this is going to be minus 3 minus 3. These simplified to 0. Minus 3x is going to give us negative 3x is equal to negative 6. Divide both sides by negative 3. And so negative 3 divided by negative 3 is 1 times x gives us x is equal to the positive 2 that we had gotten on the graph.